Hi guys, we're starting a brand new topic today, and the good news is it's new. Okay. Second piece of good news is this is something you're really going to need to know for those of you that are juniors taking the SAT next year. This is one of the biggest topics on the SAT math because for some reason they love these. Okay. It's solving a system of equations, and there's several different ways you can do this. One of them is by graphing, and we're going to touch on that in a little bit. One of them is called substitution. And the other one, which we're going to cover in the next lesson, is elimination. Okay? And it depends on what the system of equations looks like, which one makes most sense, but it's almost never graphing. Okay? So we're really not going to spend a lot of time on graphing. I'm going to show you a little bit about graphing just so you understand the concept, but you're really only going to be asked to master the substitution and the elimination. Okay, so what they mean when they say a system of equations is that there's two equations and they're both linear. Okay, they're both straight lines. So for example, and sorry, by the way, about this sheet being very light, I could not seem to get it to copy any darker. There is a copy of this on the assignment for today, a blank copy of the notes. So if that helps you, because this is so light, I did go over the equations with my black pen to make them darker, but I couldn't go over the entire assignment. Also, I generally do these in the morning, and I've been procrastinating, so it's evening. So if you see some shadows on my paper, that's why. Hopefully you're still able to read everything. Okay, so here's our first system of equations. They sometimes put one of these little set brackets out front, but don't worry about that. It's nothing that you need to do. Okay, and the two equations here, this one starts out pretty easy, are y equals 2 and x plus y equals 6. Okay, so what you're going to do is you're going to substitute. You're going to take this and you're going to take y out of this second equation, and you're going to substitute in its place what y is equal to. And y is equal to 2. Okay, so if we put the 2 down here, okay, we subtract 2 from both sides, okay, minus 2, we get x is equal to 4. Okay, then to find out what y is, normally we would have to plug this back in, but since we already knew that y was 2, we don't even need to do that. Okay, so our solution is the point 4, 2, the ordered pair 4, 2. Okay, and for part C, it asks us to graph these two lines. This is the line y equals 2. This is the line x plus y equals 6, or y equals negative 1x plus 6. And you can see that the point where these two lines cross is the point 4, 2. They're counting by 2s on this. You know, our book, they love to count by something other than 1s, okay? So this is the point where these are going to cross, and that's always going to be true when you solve a system of equations. The answer is going to always be an ordered pair, and the ordered pair is where the two lines cross. We are going to get to some strange examples where the lines don't cross or where the two lines are the same. So we're going to come back to this idea of graphing in a little bit. But first, we're going to do a couple more examples and some practice problems, or one more example and 2 practice problems of substitution. Okay? So the first step when you are doing substitution is to solve for one of the variables. And again, in this case, it's already solved for y. Okay? So we don't have to do the first step. But now we do need to substitute. So we're going to take y out of the second equation, and we're going to put 4x in its place. The rest of this equation is going to be the same. Sorry, that's kind of messy there. 5x plus 2 times 4x, because that's what y is equal to. Okay, so I'm substituting this in, is equal to 39. Okay, I'm going to distribute this. So 5x plus 8x equals 39. 5x plus 8x is 13x. Ooh, and I'm seeing that this is going to be nice. When I divide both sides by 13, I get x is 3. Okay? Now, we didn't have to do this on the first problem, but on this one we do. We have to substitute this back into our first equation to find out what y is. Well, if y is 4 times x, that means it's 4 times 3. And 4 times 3 is 12. So our ordered pair is going to be the point 3, 12. Okay, remember this is your x value, this is your y value. Okay, so that's how substitution works. You solve for one of the variables, substitute into the opposite equation, solve for one of the variables, substitute back into the original to find your other variable. Okay, and those 4 steps are summarized at the top of the second page. Solve one of the equations for one of its variables, substitute the expression from step 1 into the other equation, and solve for the other variable, and then substitute your value from step 2 into the original equation, either of them, and solve to find the value of the other variable. Okay, so we're going to try a couple of these, okay, and see how this works. Okay, now what you'll notice is different about these two is that they're not solved for one of the variables, so we have to do that first. Okay, I usually work with the first equation unless there's a reason why I can't. I could pick either of these equations, but I don't want to solve for x. And the reason why I don't is because they have numbers in front of the x's. They have coefficients. So it's much easier to solve for the y. So if I subtract this 3x from both sides, y is equal to -3 minus 3x. Okay, so I've solved for y. Now I want to substitute this in to the second equation for y. Okay, so the -2x stays the same. Y becomes this, and this is equal to 7. Okay, so I substituted. Now if I combine my like terms, -2x plus -3x is -5x. Regular algebra 1 here, I'm going to add 3 to both sides. And if I divide by -5, x is -2. Okay, I've got half my answer. Now I want to substitute this back into this equation. I could go to one of the originals, but if we solved for y, that's the easiest place to go. And I want to substitute the -2 in here. And that's what y is equal to. -3 plus 6, which is 3. So y is 3. So my ordered pair is going to be -2, 3. And the nice thing about these problems is that we can take these answers, plug them back into both of these equations, and see that they're true. Okay, so I always like it when that's possible. Okay. All right, our next example. I need to solve one of these equations for x or y. Again, I don't want to pick the y's because they have coefficients. And if I do that, they're going to be really messy. So I'm going to solve this equation for x. I'm going to add 3y to both sides. And x equals 9 plus 3y. Second step, substitute this in to the other equation for x. So 9 plus 3y plus 4y equals 2. So the rest of this stayed the same. Then I'm going to combine my like terms. I'm going to subtract 9 from both sides. This part you guys could do in your sleep. Divide by 7, and y is -1. Okay? I'm halfway there. More than half, but I have half of my answer. And I'm going to plug the -1 up here, and 9 plus -3 is equal to 6. So my x value is 6. So my ordered pair is 6, -1. Okay, now remember what this means. This means if I graph these two lines, they cross at this point. If I graph these two lines, they cross at this point. Okay? All right, unfortunately, some weird things can happen when you're solving systems of equations. And this sheet is going to show us the weird things that can happen. Okay, so let's start with this first one. Let's solve for x. Let's subtract y from both sides. Why not? Then I'm going to substitute this in for x, -4 minus y minus y equals 6. I get negative 4, distribute the negative, plus y minus y equals 6. And what happens when I have a plus y and a minus y? Well, they add up to nothing. They cancel out. And I get negative 4 is equal to 6. Is that true? No, obviously negative 4 is not equal to 6. So this is a no solution. And what this means is that if I graphed these two lines, they would never touch. How do two lines never touch? They're parallel to each other. So this is one of the strange things that can happen. So if you get a false statement, then it's a no solution and you have parallel lines. Okay? The other strange thing that can happen is going to happen on this one. Okay? So I'm going to add 3y to both sides. Then I'm going to substitute this in for x. Distribute the 4. And the same thing happens in the middle. Plus 12y minus 12y is nothing. But this time I'm left with a true statement. 24 does equal 24. So what this means is instead of the lines being parallel, they're the same line, which means whatever answers are true for this line are also true for this line. So the way that we write that is we say that there are infinitely many solutions. We don't say all real numbers, okay? Solutions, S-O-L-N, is an abbreviation for solutions. We don't say all real numbers because every number doesn't work, but the numbers that are work here on this line are also on this line. Okay, sorry, trying to line those up. Okay, so those are the two unusual cases that can happen. Okay. All right, and then on the last page, we have some story problems. And you're going to see one of these in your homework assignment as well. Okay, the first one is about a fitness center. Fitness Center A charges a $60 enrollment fee plus $35 a month. Fitness Center B has no enrollment fee but charges $45 a month. And they want you to use these equations to find out how many months will they cost the same and what will the cost be at that time. Okay, so what we want to do is we want to substitute, again, this is already solved for t, and substitute this into the other equation for t. So basically we're setting these two equal to each other. Okay, and lucky for us, they wrote the equations for us. On the SAT, sometimes you have to write the equations. Okay, so I'm going to subtract 35m. 60 equals 10m. Divide by 10, and m is equal to 6. So at 6 months, they both cost the same. And what do they cost? Well, if we put 6 in here, 45 times 6 is $270, okay? If we put the 6 into the other equation, 60 plus 35 times 6, we get the same answer, which is $270. So at 6 months, they both cost the same amount. Okay? All right, and our last example. High-speed internet provider A has a $100 setup fee plus $65 a month. High-speed internet provider B has a setup fee of $30 and $70 a month. In how many months will both providers cost the same, and what will the cost be? So basically, this is the same idea. We're going to substitute 100 plus 65m equals 30 plus 70m. Okay, I'm going to subtract the 65m from both sides. I'm going to subtract the 30 from both sides. And if I divide both sides by 5, m is going to be equal to 14. So in 14 months, both cost, and again, I'm going to substitute this back in to either one of these, or both if I want to be really sure, and see what it's going to cost at 14 months. So I'm going to do both of these. 100 plus 65 times 14 gives me 1,010. And if I plug it into the other equation, 30 plus 70 times 14 is equal to 1,010. So at 14 months, they both cost 1,010. Okay? All right, guys, good luck. The assignment is on there. It's shorter than the notes, thank goodness. This was a little bit long, 16.5 minutes, probably one of our longest videos. But good luck with the assignment. Most of you guys have seen this before, and I think you're probably going to do okay. All right, see you soon. Bye.